Statement of our problem is to evaluate a limit. The limit is taken as x's go out to negative infinity. They're getting really big. They're getting big as negative quantities. And you have a quotient. In the denominator, there's a radical. And then we have the variable x appearing in the radicand. We know that the x's are going to be negative quantities. Let's write that down. So if x's are negative quantities, and we were to put absolutes on x, we would have to introduce a minus sign in front of the absolute in order for it to be a negative quantity. You can recall that the square root of x squared is the absolute of x, and thus the absolute of x can be written down as the radical of x squared. And then carry over the minus sign. Okay, so we're going to rely on this. We're going to write down x as negative radical of x squared when we introduce x's into the denominator. So what does that mean? Well, let's do a side computation. We'll take the given expression, and we're going to take the given expression and multiply by 1. And then our choice of 1 is going to be 1 over x over itself. Okay, so distributing 1 over x into the numerator, x will go to 1, 1 will go to 1 over x. All right, that's easy. And then in the denominator, we'll simply take that radical and divide it by x. Okay. And now we're ready to use that little computation where we looked at x and rewrote x as negative radical of x squared. And the reason we need to bring that in is because we have this radical, which is controlling the radicand. In order for this x to interact with the radicand, we need a radical on the x. Well, we've accomplished that. We can then look at the quotient of radicals and write that down as the radical of a quotient, so that looking at x squared divided by x squared will lead to 1, and x divided by x squared will lead to 1 over x. And then don't forget we have a minus, so we bring the minus out to the front. Now, we did that scratch work in order to be able to nicely take the limit. Remember that x's are getting big, but as negative quantities, but 1 over big goes to 0, and 1 over big goes to 0. Now, that concept is captured in taking the limit, so let's formally write that out. That here's our original problem given to us. And thanks to our scratch work, here is a equivalent version. And now we can allow x's to become big as negative quantities. By properties of limits, we can look at the limit of this going to 0 and the limit of this again going to 0. And then simplifying that, we come up with our answer. Beautiful.